Hey, welcome back to Module 6, Lesson 1. We're going to now start with our concept development. Let's create different number lines with different unit lengths, origin, and direction of increase. So we're going to use these lines here as an example. So I want you to see that number lines can look so many different ways. So we're going to start out by 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So this number line is going to increase by 1 starting at 0. So here 0 is the origin. This is where the line originates. So it's the origin and it increases by ones. So you're following along with me. Now I am going to create another number line using halves, but I'm going to start off with my 0 being all the way over here. Now also notice that I have arrows because number lines go off into infinity. We just stop writing the numbers. So I'm going to go this way. I'm going to go 1/2. Then I'm going to go 1. Then I'm going to go 3/2. Then I'm going to go 2. Then I can go 5/2. And this can go any way you want as long as you show an origin and you show an area of increase or decrease. This is going to be 7/2. This is going to be 4. This is going to be 9/2. This is going to be 5. All right, so I created a number line. Here is the origin again. And this one increased by 1. This is starting at 0 and increasing by halves. Now, let's try another one. I'm going to have this one start at 0. And I'm going to put a half here in the middle. And I'm going to put 1 at the end. Now I get to decide what I want. How many do I want this broken up into? So what did I have this go up into? 1, 2, 3, 4. So this would be 1/4, 2/4. No. This is broken up into eighths. 1, 2, 3, 4, 5, 6, 7, 8. So this is 1/8. This is 2/8. This is 3/8. 4/8 is a half. 5/8. 6/8. 7/8. And 1. Let's do another one starting with our smallest number on the end. Let's start over here. Let's start at 0, but now we're going to increase by 15. So let's go 15, 30, 45. What comes next? 60. What comes next? 75. What comes next? 90. What comes next? 105. And what comes next? 120. So notice our number lines can start wherever we decide that they're going to start, or how much distance is going to be between each tick mark. All right, here's one more. This time I'm going to start with 0, our origin up here, and I'm going to use decimals. So there's going to be a mark under here, 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 and here. So this would be 0.1, 0.3, 0.5, 0.7, 0.9, and then 1. So we just got done creating number lines, and we chose the length, where the origin was, and the direction of increase. So we increased going downward here. We increased going upward here. We increased going from here, starting here, increasing in this direction. We started here and increased in this direction. We started here and increased in this direction. As long as your number line is labeled correctly, that is perfectly fine. Now, I'm going to have you try it on the next page. Problem 1 and 2 today is you creating your own number line. So right now, you are going to decide, how are you going to break up your number line? Where is your origin going to be? What is going to be your rate of increase? That means, are you going to have it jump by 2s? Are you going to have it jump by 1s? Are you going to have it jump by fractions, halves, decimals? So this is what you're going to do on your paper right now. You're going to decide where your origin is going to start. You're going to decide the unit lengths, and you're going to label your units. And so once you do one, once you get good at that, you might decide you want to add fractions in between. Maybe you want to decide you want to add decimals in between. So that's what I'm going to go ahead and have you do right now. And then come on back for problem. All right, problem 3. Problem 3 is we are going to describe the location of the shapes on the number line. So without touching it, could you describe where the star is located? All right, say it out loud. Yes, it's at 2.5. We don't know if that's inches, we don't know if that's centimeters, but we know it's at 2.5. What else can we tell about the star on number line 1? What can we tell? Well, you could tell how far it is from another shape. It's how far is it from another shape, right? You could tell how far the shape is from one end of the line. You could tell how far it is from 0, correct? Now, because every number line has an origin, we can use the origin as a reference point to tell the location of other points on and off the line. We can describe the location of a shape on this line by telling its coordinate. So this is the coordinate. So the coordinate tells the distance. The coordinate tells the distance from 0 to the shape. All right, on number line 1, the square's coordinate is what? The square's coordinate is 4. And then, is there another way to say that the distance from 0 to the shape is 4 units? It is 4 units down, or it could be what? 1/2. What would be 4? 8 halves, I guess, would be another way of saying it. So, what is the star's coordinate on the number line? What would you say that was? Yes, it's 2.5, correct? That is its coordinate. The square is 4. Now, on number line 2 and number line 3, a point has been plotted on each of these number lines. What is the coordinate of point A on number line 2? Then, what is the coordinate of point B on line 3? Circle it and write it down. All right. So on number line 2, A is equal to 1. On number line 3, this looks like, the number line is starting, the origin is down here and increases down here. So this is 1, 2, 3, 1, 2, 3, 1, 2, 3, 3, and what? Yes, it is 3 1/3. That is its coordinate on that point. All right, so now let's move over to the problem set. So now move over to your problem set and let's work through a few of these problems together. So, can you name the coordinate of each shape? So each shape was placed at a point on the number line S. And so notice that the number line is called line S. Give the coordinate of each point below. I think you can do that. Then you're going to plot the points on the number line here. You're going to write down the numbers that are missing and fill in each tick mark. Plot A so that its distance from the origin is 2. So 1, 2, right? Plot A so that its distance from the origin is 2. Plot R, so you're going to use the letter A to plot on the line here. Plot R so that its distance from the origin is 5/2. So you need to find 5/2 on here and plot it and call 5/2 R. You want to find where 2 is on this number line. Where would 2 be on this number line? If this is the origin, where is 2 going to fall on this number line? And you're going to call that point A. Then on the back side, plot L so that its distance from the origin is 20. So where is the origin? So if this is 50, this is 35. So where is the origin going to fall on? Remember, somewhere has to start with 0 and move up. And then you need to figure out how these are broken up. What is the distance in these lines here? Then part D. Plot, and so you need to call 20 L. Then plot a point T so that its distance from the origin is 2/3 more than that of S. So 2/3 plus S. Well, you need to first figure out what S is in order to find T. Then number line G, notice that they've named the number line. They call the number line G, is labeled from 0 to 6. Use number line G below to answer the questions. So there are, how many questions here? 1, 2, 3, 4, 5, 6. There are 6 questions, and you're going to do everything that's on here, that all of these questions that they're asking you, you're going to show on the number line G. Then we have problems 4 and 5. Problem 4, Mrs. Fan asked her 5th grade class to create a number line. Lennox created the number line below? Parks, so these are kids' names, Parks and Lennox. So Parks said, Lennox number line is wrong because numbers should always increase from left to right. Who is correct? And explain why. Number 5. A pirate marked the palm tree on his treasure map and buried his treasure 30 feet away. Do you think he will be able to easily find his treasure when he returns? Why or why not? What might he have? What might he do to make it easier to find? Look for the treasure 30 feet from this tree. So, if you were going to bury a treasure, what would you draw in order to be able to find that treasure again? That is number 5. Here is your exit ticket. Label and answer the questions. Here is your homework. On the back, doing the exact same thing we did in the problem set. And then Mr. Baker's 5th grade class buried a time capsule in the field behind the school. They drew a map and marked the location of the capsule with an X so that his class can dig it up in 10 years. What could Mr. Baker's class have done to make the capsule easier to find? So you're going to answer this question here. All right, good luck, and thank you so much.